Alright, welcome to our last and final video where we're going to be talking about the quadratic formula, which is basically a formula that allows us to skip using that method of completing the square. So I have the quadratic formula written in my notes. It's right here. In this class, you do not need to memorize this formula, but you will be asked to memorize this in Math 121, so just as a heads up. This formula says that if you have a quadratic equation equal to 0, the solution can be found with that formula, where a is the number in front of the x squared, b is the number in front of the x, and c is the constant. So if I want to solve example a using the quadratic formula, my a would be 1, my b is -3, and my c is 2. I can just take these numbers and plug them right into that formula. And so let's see, b was -3, so -3 is a +3, plus or minus the square root. -3 squared is 9, and then 4 times 1 times 2 is 8. And all over 2 times 1, or 2. So x is 3 plus or minus the square root of 1 over 2. And square root of 1 is 1. So that means x could equal 3 plus 1, which is 4, over 2. That's 2. Or x could equal 3 minus 1, which is 2 over 2, or 1. So my solutions to this equation are x equal 2 and x equal 1. Now I want to point out that the quadratic formula is great because it always works, but it isn't always the fastest way to solve something. If the directions hadn't told me how to solve this equation, x squared minus 3x plus 2 equals 0, I would have probably factored this. I know that 2 times 1 is 2, and if they're both negative, that adds up to 3. And so I get the exact same solutions. Let's see, x equal 1 and x equal 2. But the nice thing about the quadratic formula is it's something that always works. It even works in a problem like this. 3x squared minus 7 equals 0, where you seem to have a missing term. In this case, the a would be 3, but there's no x term, so b is 0, and the constant is -7. So plugging that into my quadratic formula, x equals -b plus or minus b squared minus 4 times a times c, all over 2 times a. Well, -0, I don't need to write that down. So just plus or minus 0 minus a negative 84 all over 6. Minus a minus becomes a plus. So I've got plus or minus root 84 over 6. And this can be simplified because 84 is the same thing as 4 times 21. And square root of 4 is 2. So I get plus or minus 2 root 21 over 6. And then finally, 2 over 6 can be reduced to 1/3. And so my final answer is plus or minus root 21 over 3. So again, the quadratic formula works in any quadratic equation. If it feels like a term is missing, you just put in a 0 for that number. All right, one more example with a quadratic formula. In this problem, I actually have rational expressions. I have fractions in the problem. So I'm going to take this equation and I'm going to multiply everything by the LCD to clear the fractions. And in this case, the LCD is x squared. So I am going to multiply every single term in this equation by x squared. So 9 over x times x squared, one of the x's cancel, and you're left with 9x. minus 2 times x squared equals 5 over x squared times x squared. The x squareds cancel, and we're left with 5. Now, this equation's a little bit different than the previous examples in that I have to set this to 0. The quadratic formula only applies if one side equals 0. It doesn't matter which side you set equal to 0. So maybe I'll just subtract that 5. So now that I've set this thing equal to 0, let's see, my a is negative 2, my b is 9, and my c is negative 5. And so I'm just going to take those numbers, plug them into my formula. So x is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So negative 9 plus or minus square root of 81, and then I've got 3 negatives there. Minus 4, minus 2, minus 5. That is a minus 40 all over negative 4. And 81 minus 40 is 41. And so my answer is negative 9 plus or minus root 41 over negative 4. Okay, so again, a couple of main ideas in this problem. We had to multiply everything by the LCD to clear the fractions. And then we had to set one side equal to 0 before we could use that quadratic formula. So finally, I want to finish this discussion by talking about how do we solve quadratic equations in general, if they don't tell us what to do. And so we have learned 4 different methods that can be used to solve quadratic equations. The square root method, where you take the square root of both sides. This only works if the problem has one term with an x in it. It could be an x squared, but you can't have multiple x's in the equation. And then we learned about factoring, and that only works in special cases. And then the other 2 methods we learned were the quadratic formula and completing the square. And so to solve these equations, first thing I would do is try 1 or 2. Can you take the square root? Can you factor? And then if not, you have a choice. And honestly, most people, myself included, would just choose to use the quadratic formula. So let's run through a couple of examples. In this first one, x squared plus 2x plus 1 equals 0, the square root method is not going to work because there's 2 terms with x's in it. So I'm going to see if I can factor this thing. Let's see, I need product of 1, sum of 2. I think 1 and 1 will work. So that means x equal negative 1. So factoring was definitely the fastest way to solve this method, or this equation. Part B, does the square root method work? Well, yeah, there's only one term with an x in it. So I'm going to isolate the x squared. I'm going to do that by moving the 8 over, adding 8, and then dividing by 4. And so I get x squared equals 2. And then we can take the square root of both sides. Don't forget that plus or minus. And I get x equals plus or minus root 2. So the square root method, when it works, is also a very fast method. Let's see, part C. Can we use the square root method? No, there's 2 terms with x. So I'm going to see if I can factor. Let's see, can we factor this thing? Yes, there's actually a GCF here. I can take an x out, and I'm left with 3x minus 4. Oh, and that's it for the factoring. Now I just set the factors to 0. X could equal 0, or 3x minus 4 could equal 0. So I guess one of my answers is x equal 0. And then for the other one, I add the 4. I divide by 3. So x equal 4/3. All right, 2 more examples. I always ask myself first, can I use the square root method? Well, yes, there's only one x in the problem. So I'm going to take the square root of both sides. Don't forget the plus or minus. That gives me x minus 5 equals plus or minus 5. So x minus 5 equals 5, or x minus 5 equals negative 5. If I add the 5, I get x equal 10, or x equals 0. Finally, one more example. Let's see, can we use the square root method? Well, no, there's two x's. Can we factor? I would need to find two numbers with a product of negative 14 and a sum of 4. 2 times negative 7 was negative 14. So let's see, 1 and 14, or 2 and 7, there is no way I can get a 4 out of that. Okay, so factoring is not going to work. I'm just going to erase that. And so once you try the square root method and factoring, and neither of them work here, that's when you know you have to use the quadratic formula. So one side equals 0, that's good. My a is 2, my b is 4, the c is 7. I'm going to go ahead and plug those numbers into the quadratic formula. And then let's see, we get negative 4 plus or minus the square root of 16 minus a minus becomes a plus. 4 times 2 times 7 is 56, and then over 4. So that's negative 4 plus or minus the square root of 72 over 4. And I think we can simplify this because 72 is 36 times 2. And 36 is a perfect square. That would be negative 4 plus or minus 6 root 2 over 4. So I actually have a common factor of 2 here. All 3 of these terms can be divided by 2. And it's important that all 3 are divisible by 2. We wouldn't be able to cancel anything out if we couldn't take it out of all 3 of the terms. And that's because we can only cancel out common factors. And so there's my final answer. X is negative 2 plus or minus 3 root 2 over 2. All right, that is it. Let me know if you have any questions.